Hi, my name is Ashley Kelly. Thank you for joining our session today, Rethink Your Service Strategy to Meet Your Data Center Sustainability Goals. This is the last webinar in our Data Center Sustainability series. Before we get started, I'm just going to go over a few things. So there's a Q&A panel to the right of the slides, and during the presentation, you can submit questions at any time by entering them there. Our speaker, Lee, will address as many as possible at the end of the presentation. You'll receive an email later this week with a recording of the presentation and a copy of these materials. This 5-part webinar series covers sustainability trends and innovative technologies that support reliable data center operations while consciously managing environmental impact. You can catch up on any of the previous webinars from this series using the link in the reminder email you received for this session. Your speaker today is Lee Todd. He's our Global Product Manager for Data Center Services at ABB. And now I will turn it over to Lee.
Thanks a lot, Ashley. Okay, good morning, good afternoon, and good evening, guys. I'd like to start by introducing myself. My name is Lee Todd. I'm the Global Product Manager for Service Solutions within ABB's Electrification business. I've been in the electricity industry now for over 30 years with experience from the grid all the way through to the socket outlets. Over the next 30 minutes, I'd like to take you on a journey to rethink your service strategy to meet your sustainability goals, reduce costs, and increase the efficiency of your plant. We're going to cover safety, how to comply with updated legal regulations, and improve safety for operational personnel with, for example, arc protection, both passive and active. I want to tell you how we can help reduce costs and improve production continuity with improved energy efficiency and energy management, and by looking at power quality and protection. Reduce your energy consumption, look at power factor correction and network protection and balancing. We'll then look at how new technologies in service are driving asset performance and optimization by looking at the reliability and lifecycle management of your assets, safeguarding and lifetime extension of your investments, upgrading of assets to current state of the art, and perhaps more importantly, improving the overall efficiency of your maintenance and sustainability of your site. So let's get started. First of all, we'll look at safety, both from a consultative approach and from a protection of people and equipment. The first step to improving operational safety, as all of you know, is to understand the site condition. We can help you with this by performing detailed plant assessments to understand the condition and relative risk of failure to prevent damage to your plant, injury to your people, and help prevent production stops. We can also perform detailed network analysis to look at, but not limited to, short circuit calculations and arc studies. We can help and advise on how your network is performing and how to drive sustainable optimization strategies. We can also offer you training, both for you and your teams operationally at sites, develop procedures to ensure safe working practices and in maintaining and optimizing your site, as well as looking at minimum downtime installations and commissioning of retrofit solutions, both for low and medium voltage assets and DC systems, to provide life cycle extension, as well as improving operational efficiency and safety. Let's look at what my site condition site assessment is and why the service is important for you and your teams to meet your sustainability goals. So, what's my site condition? My site condition supports you in finding the most appropriate business decisions related to your allocation of operational budgets. This is made possible by helping you to strategically direct and allocate budgets on an asset risk condition basis. This is the first step in the process of enabling you to move from a time-based maintenance towards advanced maintenance methodologies. Through My Site Condition, we'll provide you with an assessment of the strategic importance of your site's equipment, the actual condition of the assets you have on site, and your network. Critical points of failure within your network are covered to look at mitigation strategies, and in an available historical data file, we'll share with you maintenance and failures and points of upgrade. We will provide an analysis of operational and asset safety, and last but not least, an analysis of product life cycle status. The key benefits that you'll take away from this are understanding the condition status with an objective, up-to-date overview of each of the single components on your system and the condition of those components. It will help you to reduce the risk by receiving detailed analysis on risk reduction opportunities, as well as recommended mitigation actions. It'll also provide you with condition-based budget allocation recommendations to use where asset reliability or safety might be endangering the future of your site structure. The outcome of the assessments are in detailed reports and illustrations. You can see an example of this on the middle of the slide. It not only explains, but it visualizes the actual status of the overall plant condition and each asset. It will also show you how performance and safety can be improved, availability increased, and your service needs prioritized. In many cases, minor preventative maintenance actions can be performed to improve the condition of the equipment whilst the assessment is being performed and whilst data is being collected. Condition and predictive based are by far the most effective maintenance strategies and more sustainable strategies. Studies have shown that a substantial portion of operational budget can be used far more effectively by performing assessments in order to prioritize and focus your maintenance teams. This next page shows you an example from where My Site Condition has been applied at a water authority network control center in Iraq. In this case, the customer wanted a detailed analysis and assessment of their electrical system. They wanted it to cover the main incoming medium voltage supply from the utility, but also wanted it to be fully inclusive of the diesel generators, safety procedures, and tools. The local service team in the region provided on-site assessment, My Site Condition data collection, and a full series of reports. The customer's feedback from that assessment was that it was very effective. And the report highlighted clearly the criticalities and allowed them, more importantly, to budget and to plan for essential mitigation actions. We'd be more than happy to discuss with you My Site Condition on an individual basis, how this can be applied to your sites, and how the tailored benefits you could expect to receive by taking advantage of this service. And if any of you have any questions on that, please feel free to reach out to me directly or to Ashley or any of the team. One specific area of safety that I want to focus on is guarding against arc flash and arc blast. An arc flash, as you know, is the light and heat produced from an arc fault that is supplied with sufficient electrical energy to cause substantial damage, fire, injury, or harm. A phenomenon of electrical arcs is that the arc experiences, as you know, a negative resistance, which in turn causes the electrical resistance to decrease as the arc temperature increases proportionally. More than 2,000 workers in the US alone last year were treated for specialized burns related to arc flash injuries. This led to over 300 deaths. Around 80% of the electrical related accidents and fatalities that occur on any site involve qualified workers and are caused by arc flash and arc blast. Even trained people get hurt. The potential cost of this can easily be between $1 to $15 million. And if you think about it, that includes everything from the cost of equipment, the cost of downtime of your systems, insurance, and compensation costs. So, how can we protect people and equipment? We can help in two ways. The first is passive protection in the form of updated, upgraded switchgear designed and certified against internal arc faults. For example, medium voltage switchgear, safe gear, or unigear, which has an internal arc withstand of 50 kA and provides you with full AFLR protection to the operators. That's all around front, lateral, and rear protection. Next, and perhaps more important or appropriate at this, is that we have active solutions that can be built in from the factory or can be retrofitted to existing equipment in your plants. An example of this type of solution are the ultra fast acting earth switch or the Relion series of relays with integrated arc fault protection. We also have the Tuvok arc guard system and a full lineup of medium and low voltage circuit breakers as a retrofit solution to enable you to bring your system up to a more sustainable and modern nature. So, why should you look to do this now? The answer's simple. Arc faults are the most serious fault within your power system. The cost to life and equipment and outages are real. Our active solutions can extinguish an arc fault in less than 4 milliseconds in the application of the ultra fast acting earth switch, and typically between 60 to 80 milliseconds using an arc protection Relion relay, obviously subject to the switching and tripping time of your breakers. I'd like to show you now just a couple of examples where arc mitigation strategies have been applied. The first is a telecom control center in Brazil. The customer here wanted to improve the operational safety of their existing switchgear, but made very specific requests that it must minimize the downtime of the data acquisition and the operation during any upgrades, and it also had to meet future insurance and risk certification as well as the company requirements. As a national company within Brazil, you can imagine there are a lot of standards that they had to comply with, both internally as well as standard regulatory. The service team locally in Brazil met this challenge and upgraded the protection and control system to the Relion REA arc protection solution. This upgrade was completed on non-ABB low voltage equipment. This REA solution provides protection, detection of an arc, and sends a trip signal to the breaker within 2.5 milliseconds. So extremely fast acting to protect both the operator and protect damage to the equipment. This next example is of a data center with a combination of both ABB and non-ABB medium voltage switchgears. In this request, the customer had a severe failure on site, and that had led to a catastrophic system-wide shutdown. The customer requested for the highest possible protection for his people, his assets, all on his medium voltage network. Again, the service team locally provided and installed and commissioned ultra fast acting earth switches. After validation of the advantage of these ultra fast acting switches, this site then rolled out this innovative solution across the non-ABB switchgear as well as their ABB switchgear on site. Next, I want to briefly touch on power quality and power sustainability. Your system efficiency and service continuity can be affected by 3 key factors. The first of those is reliability, quality, and then last is disturbances. Let's first of all take a look at reliability. ABB has an extensive range of UPSs from single phase to 3-phase and for both low and medium voltage applications in data centers. Our units provide power protection for your sensitive loads from a few kilowatt up to many megawatts. Secondly, we have power factor and harmonics. The power you buy comes in two distinct parts. Let's think of it as a frothy latte. You can think of the coffee body as active power, and that you can use for your process and system, while the froth on top is what we call your reactive power. As all of you are aware, some is useful, but too much reactive power is simply a waste, like the foam you leave behind in your coffee glass. Your power factor is the relationship between active and reactive power on your network. The good news is we can help to get that balance just right for you. A low power factor might be only one of the symptoms of a range of power quality problems that you're facing on your network. That can reduce both reliability and efficiency of your electrical equipment on your system. A full survey will detect any power quality issues such as harmonics, flicker, or unbalanced loads. We can then draw on our range of state-of-the-art equipment, including active filters, to provide you with the ideal cost-effective solution. And finally, we have power voltage conditioners. Power supply disturbances can interrupt your operation and your system, resulting in loss of data, loss of system, and of course, loss of equipment. Fortunately, we have the latest power technology to prevent these interruptions. This is installed between the incoming supply and the equipment loads. An active voltage conditioner senses power disturbances such as voltage sag from adverse weather, and that acts extremely quickly to correct the event before anything can take effect on your system. This next slide shows an example of where power quality was an issue. In this case, the customer, a water utility company in the US, had an issue that the power factor was in the low 80s. And because of that, the utility was charging them penalty charges for the power supply coming in. The request to ABB was simple. Firstly, they wanted to know the state of their network and the condition. And then secondly, they wanted us to propose a solution to improve the power factor to a greater point than 92%. That way they would avoid those penalty charges from the utility, as well as reducing their energy costs. The local service team in that state provided them a detailed analysis of all the issues, which resulted in the installation and commissioning of a medium voltage capacitor bank. This analysis and installation saved the customer, in this case, around $1,500 a month, and that gave them a return on investment of less than 5 years, as well as improving the sustainability and power consumption on the site. Now comes the really clever part. Let's talk about asset performance and asset optimization. Asset performance management systems act to improve the reliability, to keep your systems up and running, the availability of physical assets and your installed equipment, while minimizing the risk of failure of both the subsequent and indirect costs and your operating costs. For effective asset management, as all of you know, asset owners need to be aware of the condition of the switchgear they have on site, the breakers they have on site, the risk of what happens if I lose a particular breaker feeder. Do I lose my system, part of my system, or do I lose just the lights? What's the probability of failure in real time across all your assets on your system? What life cycle are you in? On your switchgear, on your breakers? Are spares totally available? Is my equipment current? Is my equipment obsolete? And lastly, but perhaps more importantly, when does that trigger a service retrofit to extend the life of the switchgear and reduce the impact to the system and solution that you're delivering? So, what are the maintenance strategies available to you, and what's the cost? Well, you could run your site to failure and risk a total system loss. Of course, none of you would do that. You could move up the ladder and go to time-based, which does not take into account if a breaker has switched once or it switched 300 times, if that occurred in 1 year or in multiple years. Next, you could look at usage-based maintenance. Do I know what my usage is and what that usage reflects? Did a breaker open and close because we intended to, or has it opened and closed in anger? The best option to maximize your system continuity and reduce your service cost is condition-based, using analytical data that allows you to get to the holy grail, which of course is predictive. So how can we help you get there? Let's take a look at operational cost. A maintenance manual might say that you have to perform maintenance every 3 years, and you need to check, for example, breaker timing. With condition monitoring, you can collect that every time you switch a device, and that data is collected centralized, reducing the cost per asset for maintenance. Typically, switching to this kind of system for maintenance will decrease your overall service costs by around 30%. Next, let's take a look at maximizing uptime and continuity of service. With digitization-based maintenance, the systems will inform you before an asset is about to fail and allow you to plan when to change an asset. And this is key. Without this, let's consider that you lose a charging motor on a circuit breaker. And let's consider that occurs at the worst possible time of the year, let's say Christmas Eve. So let's say the cost of a motor is $100. You might think, not pity, it's not that significant. However, labor at Christmas Eve might cost you $2,000. Unexpected failure, like loose connections, climatic and atmospheric contamination, etc., will not go away. These are conditions which are beyond prediction. However, condition monitoring and analytics will make it more predictable. When we look at safety, moving to condition-based predictive maintenance keeps your personnel away from unnecessary proximity to switchgear. And if you use remote HMIs, these allow you to have real-time data visibility. As we discussed earlier, and perhaps very importantly here, arc is the biggest risk to your electrical system. So how can we sum up time benefits of condition-based predictive maintenance? How do we achieve a 30% saving? Well, first of all, let's look at availability of the asset and the reduced downtime. Then you can look at it on reliability of the system and the architecture through optimized maintenance. And lastly, the holy grail here that drives that cost down is predictability, knowing when to replace an asset before it fails. All of this results in operational savings. As we've been implementing this over the years, one of the things that I am very conscious of is gaining your feedback, our customer feedback. And on the screen at the moment are a couple of examples where we've had feedback from an electrical services manager and a director of operations. The first one, as you can read, they wanted to track the health and condition of the asset and predict potential failures. And the key to them was budgeting and planning and estimation of remaining useful life. By using condition and predictive-based maintenance with digital analytics, it allows you to answer all those questions in one. You can understand how many times something switched. You can understand the timing, for example, on a breaker, and over a period, you can monitor the timing as it decreases or increases, and therefore, with the algorithms that we have, predict the useful life that is left in that breaker. The second example here is around availability and predictability. Again, these are the same coin, but a different side of that coin, allowing you with digital information to understand how you get the best availability, again, by understanding when do you need to take something out for maintenance versus taking it out because it happens to be 12 months and the manual says you have to do. With this particular customer, the changes that we made site by implementing digital persuaded them to switch all new switchgear tenders to contain digital diagnostic. So, to make all this possible, we've created a new digital world that pulls together my site condition, which is the comprehensive site assessment without sensors, as we've discussed, gathering information on your asset, understanding the condition of your asset, and understanding what has happened in the past in terms of maintenance and outages. The second piece of this is condition monitoring with sensors. So combining the MySite Care and SweetCom with both thermal, partial discharge sensors to understand what that condition monitoring looks like. And then the third piece of this is an Industry 4.0 cloud solution, all in one place to create a predictive maintenance algorithm layer. This will then help you predict and understand when you need to change something, how you need to change something, and allow you to allocate budgets to be more sustainable. So, how do we collect all the data to get to one holistic view as you've just seen? SweetCom is one device. It's one relay that's mounted to your switchgear that all the relays in your switchgear talk to. All the sensors are connected to it and gives you one point of contact for all the digital assets. SweetCom will collect data not only from ABB's assets, but also from non-ABB assets. So it's irrelevant of which manufacturer you have for switchgear or for relays. SweetCom is applied, if you can imagine, in layers. Taking data from your relays is one example, and that can be open close times, number of operations. You might ask, why use SweetCom for this if my relay has the data? Well, relays being mission critical are also protected. No one wants to inadvertently alter any settings or affect the operation of your system or the operation of your protection. Additionally, SweetCom can be read remotely, either via Android or Apple device on a local or remote HMI, and that allows you to keep personnel at a distance from the switchgear. If you imagine pulling any of this data any other way, you finish up standing in front of the switchboard and physically making contact with your protection relays. SweetCom's advanced analytics are not solely reliant on relay data or sensor data, but they also take advantage of the many years of data that we have collected on our assets in the field. The overview image that you see on the right side of the page here shows you the system architecture and how it would look on a typical medium voltage switchboard. You have the SweetCom unit connected to the relays. That is on a 61850 IEC backbone. SweetCom also is connected to both temperature and partial discharge sensors. It's then connected to the site SCADA, or an ECS or a DCS, and or the Ability Cloud via a dedicated gateway. On-site solutions can be via a HMI or via an app on your phone or on a tablet. The handheld devices that we use on this system connect via the SweetCom's QR code. Each SweetCom unit has a unique QR code that allows you to read directly from that unit. After a period of inactivity, that unit then auto disconnects. SweetCom sensors come in two basic flavors. Let's take a look at temperature sensors. These are wireless sensors and again can be applied to any switchgear, either at the factory or in the field at your site, or to third-party switchgear. The sensors form what we call a closed loop system, and that's really via the sensor, the antenna in the switchboard, and of course the SweetCom unit. Secondly, we have partial discharge sensors that can be applied either by utilizing the capacitive voltage dividing sensor technology. This is typical and standard in most IEC equipment, or by utilizing for ANSI and NEMA, we have temperature and what we call ultra high frequency detection. The holistic predictive maintenance architecture looks like this. And I know it's a very busy looking slide, so I'll talk you through it from left to right. My Remote Care Industry 4.0, all the collection data and uploads to the Azure platform to enable you to have a 24-hour, 365-day-a-year monitoring. This can either be at home, it can be in the office, it can be on the factory, it can be via a mono-directional link. What this means is the link eliminates the possibility to control the equipment remotely. It's one direction just to provide you with data feeds to your phone or tablet. The link also, you can think about this asset health as continuously monitoring like a digital fingerprint. It continually analyzes the probability and risk based on all the data points it collects in that system. This next example is where low voltage and motor condition monitoring has been applied. What I want to talk about now, if I can, is a little bit about our digitalization solutions and where we are and where our local service teams are. We have 10 digital solution centers globally. Each of these centers contains engineering teams that are able to consult, able to design and implement very tailored solutions to your energy, efficiency, and sustainability needs, both for digitization and for asset management. In addition to this, we have 40+ service centers globally that support you, our customer, in adaptive predictive maintenance. These can either be by digital maintenance or by the offering of a power care service agreement with local or remote support and extended warranty. So just to finish on where we are, I'd like to talk a little bit about what the summary of today is, and that is about safety. It's about our commitment to you to bring you world-class systems, solutions, and products that make your system safe, both from an architecture and a personnel perspective. It's about efficiency and production continuity, enabling the energy efficiency and energy flow on your site to maximize power management solutions and your production continuity. Asset performance and optimization, digital monitoring of reliability and efficiency of your assets to optimize the operation and maintenance of your system and process. And perhaps last, but definitely not least, flexibility and sustainability overall. The digital solutions that we can offer give you flexible, scalable, and modular solutions, which also allow for efficient integration of future renewables and e-mobility onto your network. So I'd like to say at that point, thank you very much for your attention over the last 30 minutes. And I appreciate there is a lot of information that we've just gone through, some of which is extremely technical and others which may or may not be applicable to your site. But we hold ourselves open to be able to provide a service to you. And if you have any questions at all, please feel free to reach out either to myself or to one of the team, and we will be more than happy to sit down and discuss any of the opportunities with you. Ashley, over to you.
Thank you, Lee. Thank you for all of that information. We'll now take some questions from the audience. If you would still like to ask a question, you can enter that into the Q&A section, and we will get to as many as we have time for. So the first is, how easy is it to adapt existing equipment with the digital upgrades on site during operations?
It's very easy. First of all, we would normally perform a survey to look at the equipment that you have. The installation of the digital head unit, the SWECOM unit, as you see, is basically a relay. So it would involve replacing one of the doors, which we would do off-site, and then we would bring it to the site for installation. You would have a very small power outage whilst we're installing, for example, temperature sensors or any other form of sensor within the switchboard, such as partial discharge. And then the site would be fully operational again with that minimum amount of downtime.
Okay. How would I ask for a site survey and report on my system status?
So the easiest way of doing that is to reach out to your local data center or service team from ABB, or you can use the web portals that we have, and you can apply through that, and we're more than happy to follow up. Or alternatively, you can reach out to any of this team on the call, and we'll be happy to pass your details over to somebody who will organize a call with you.
Great. Yeah. Will upgrading the protection and control relays make my switchgear arc-proof?
Great question. It doesn't make it arc proof, but what it does do is make it arc resistant. So what you have is the switchgear itself will still be normal switchgear, but in the event of an arc occurring, the person stood in front of it will be provided a level of safety due to the fact that the disconnection time is typically less than 60 to 80 milliseconds in the case of a rely-on relay, or using an ultra-fast earth switch around 4 milliseconds.
Oh, okay. Let's see. What savings can we expect on switchgear operations if making the move to predictive maintenance?
Another really good question. If you look at the analytics and the statistics that we had from sites that are operating digital predictive maintenance, the average saving is in excess of 30%. And that's because of the fact that you are no longer performing maintenance unnecessarily. You're using more sustainable maintenance methods in terms of only doing maintenance when the system actually needs it. Now, what that might result in some instances, you may do a little bit more maintenance because of the operation on site. But in the majority of instances, it allows you to extend that maintenance window out, which reduces your operational cost by typically around 30%.
Thank you. I see one more. ABB helped me with a carbon neutral challenge.
Yeah, so that is really where sustainability comes in and where digital comes in. By digitizing your network and your system, the addition of things like solar powers or micro wind turbines, or even adding e-mobility to your site becomes much simpler. The allocation of power on that site and the development and diversification from the grid to your sustainable sources can be managed then through that digital interface. So we can help in multiple ways. One, with the digital service solution, and two, by also helping you looking at what type of carbon neutral solution you can provide. And a good example is many of the bus stations that we have in Europe now are looking to switch to electric buses, and we're installing a number of those, especially in places like Germany and France, where the bus station, instead of the buses pulling up and just waiting for passengers, they actually pull up over a charging area that allows that to charge the batteries on the bus. So again, moving to a more sustainable basis through solar energy, providing that charge rather than it coming in from the grid.
Okay, very interesting. I don't see any other questions from the audience. Is there anything that you want to add before we close out today, Lee?
Thanks, Ashley. Yeah, again, my closing comment here, guys, is a lot of information in the presentation, and I appreciate the time that you have given us today. We would love the opportunity to sit down with you and discuss further how we can help your site, how we can help your sustainability goals, and how we can help you develop a maintenance strategy. So please feel free to reach out to us, and we will be more than happy to help.
Thank you, Lee, and thank you everyone for your attention today. When you exit this session, you'll be prompted to fill out a survey, and we appreciate any feedback you have on today's event. But we hope you enjoyed the Data Center Sustainability webinar series, and have a nice day.
Thank you.